Hello, welcome again to class. Thank you so much for staying tuned, and thank you so much for liking, subscribing, and also following. Thank you so much for being around. I want to apologize, it's been a while that we've not showed up, but thank God we're back. Now we'll continue on Surds. Previously we had this, we've defined Surds and looked at it in respect to rational numbers and rational numbers, explaining what both means. Now you want to go back to the previous video so that you would remind yourself or perhaps get to know. If you've not, if you just joined us for the first time and at the end of or in the middle of watching this you discover you liked it, you can subscribe to get more content like this, like and also share so that you can also make others know you're gaining benefits. Subscribe and like. Thank you so much. So let's go in straight. Now previously we had this, we have started, we defined it, we did rational numbers, natural numbers, and then we looked at basic forms of surds, how you can transform surds like this to another, in which case we can bring this down and check the previous video. You get to know I solved this and I solved this and I say take this an assignment. So I'm going to be solving this for those who actually did the assignments, and then we'll look at transformation of these sorts. Now in other words, we'll be reversing to the previous. Now we moved from this form to this format, and now in this particular what we're doing today, we'll be reversing, moving from this format to this. So let's go back to what we did in the previous class. We did this. So let me start from the assignment, or let me do the assignment here. The assignment, we had a solution to the assignment. So we're told to take this to the basic form. The basic form. So we had 72. Now what we said, you would ask yourself, look at your multiplication table. Now I've personally been an advocate to people buying notebooks that have a multiplication table and other metric values, other metric conversion values. Metric conversion tables, I mean, those things are going to help education. Those others that just keep some stories are not going to help, because when you're solving maths, physics, further mathematics, including chemistry, you may want to switch from one unit of measurement to another, so you look at these things quickly. You know your multiplication table, these are one of the foundation of doing well in mathematics. So with this, ask yourself, what is 72? Now 72 is the same thing as what? 72 is the same thing as what? 8 times 9, or whichever way you say 9 times 8. 9 times 8. And then 72 is the same thing as, this is 18 times 4, or if you like say 4 times 18. And then 72 is the same thing as 6, 3. That's 6 times 2. Now with this we'll be able to find this reduced to from this form to this. Now what happened is this: if you look at this, we'll look at the situation where one of the digits, one of the numbers will be one of the numbers has a perfect square root. Now look at this. 72 is quite tricky because all the three possible this actually have one perfect square root. This one has a perfect square root. Square root of 36 is 6. The square root of 4 is 2. The square root of 9 is actually 3. So we'll pick one. Now let me see, if we solve all three, you'll see what we'll do. Now if I have the square root of this and the square root, that means from the first row, that is A times B, that is the product rule. AB, the square root of A times B, the same thing still means the square root of A times B, which still means the square root of what? A times the square root of B. That's what it means. Now, having known this, I proceed here. So I can put the square root to see how we'll get. And this, so this gives me the same thing as saying the square root of 9 times the square root of 8, right? So what's the square root of 9? It gives me what? This gives me 3 times root 8, right? Which is what? 3 root 8. You see it? Now, if I want to solve this now, if I bring this down, this will be root 4 times root 18. So what would this be? The square root of 4 is 2. 2 times the square root of 18. 2 times is going to be 2 root 18. You see it? This is a simplified form. And then look at this one too. This one can give us something. It can be the square root. This one can become the square root of 36 times the square root of 2. This one is the perfect square root. The perfect square root of 36, because the 6 times 6 that will give you 36. That means the square root of 36 is actually 6. Now don't put the square root on the 6 again, because this square root of 36 is just the same thing as 6. Just the same thing. Just the same thing. So you don't need to come here and put the square root again. So what that means to have is, so this time the square root of 2, 6 raised to 2. Now, in this is true, this is true, this is true. Now, whichever you go, but this is best, because this one gives us a number where the square root of this, the possibility of this having the square root is lower. So this one is preferred. So this is going to be better acceptable than this and this. So take this one. So what we have here, we're going to use this. All three can go. So we'll have it as the square root of what? 36 times 2. And which is the same thing as saying the root of 36 times the root of 2. What's the square root of 36? We've already done it here. This is 6 times square root of 2. Then it's going to be 6. 6 root 2. The answer. Now, in this case, that's doing the assignment we had. Now, coming back to what we have today, let's see what we have. In this case now, we'll be doing the reverse. How do we move from here to here? Having known that this one, this part, let's pick this. This is actually, this 6 root 2 actually meant this 6 was multiplied by itself with the square root times this 2. So 6 times this is what? And let me bring it here. Let's bring this. 6 root 2. Separate it means 6 times root 2. Now, how do we bring this one? To make it look like this is to put a number, multiply this one by itself and put a square root on it. That is, find the square of 6 and put a square root of it, in which case it's going to be 6 raised to the power 2. So 6 raised to the power of 2 square root of 2. Because in maths, this will cancel this and then we'll return back to this. But I want to use here to get back to the next. So it's the same thing. So what we'll still have is 6, that is 6 raised to the power of 2 now. 6 raised to the power of 2. Okay. 6 raised to the power of 2 is what? 36 times 2. You bring them together, it becomes 36 times 2. And then 72. So you now see from here, we moved to here. And from here, we come back here. It's possible in math. So you can go from here to the square and from here back to this place. Now, let's bring it. The same thing is applicable here. Let's pick them one by one. The question number 1 is solution. Number 1, transform this back to basic form. So we have number 1, 2 to the power of 3. What does it mean? It also means 2 times. Or should I do it this way? This way, okay? It still means it applies 2 to the power of 3. Now, what is it that will make this look like this? It is to put square root and square and square root are opposites. So if I put one, that should cancel the other. This and this will cancel the other. Normally this will cancel this. And then you have your A standing. Well, how about if I have my A standing and I want to make it look like this. In order to make it look like this, I will introduce a square. And in order to make it still be that I've not changed it, I'll still produce. So I have given it a cap, and I've given it a cap, and I've also given it a square in quotes, cap in quotes. So this cancel this will still return us to this. So in other words, a squared is still the same thing. A squared square, the square root of a squared is still the same thing as just a. Right? Good. Practice them. So what does this mean? This one means 2 squared. And then I introduce the square root. Because this 2 squared, the square root of 2 squared is the same as 2. Because if this cancels this, what will still remain is just 2. If this cancels this, what will remain is just 2. So I decided to go the other way. So let's leave it this way. The square root of 2 over this, then times the square root of 3. Have you seen it? So as we progress, what is this? What is this? What do we have here? We now have, wow, I shouldn't have done this this way. Should I solve it here? Solve it here, solve it here. Okay, let me start so that I'll do it this way instead of going horizontally, so I don't rub this off. Okay, let me start all over again and do it here, this way. So this means, again, it means the 2 times the square root of 3. And then this is what? The square root of 2. 2 raised to the power 2 times 3. What is this? 2 raised to the power 2 is 4. The square root sign is still there, times root 3. And bring the 2 of them, marry them together, becomes 4 times 3. Square root together. 4 times 3 is what? The square root of 12. So you now see number 1 is done. And I picked number 2. So that means it was this that was solved to give this. And it was this you found that was solved to give this. So you go whichever way in maths. So if I pick the second one, the same thing applies. 7 root 2. Sorry, 7 root 2. What does it mean? It means that 7 times root 2. What does it mean? 7 is the same thing as the square root of 7 squared. The square root of 7 squared times 2. 7 squared is the same thing as what? Square root of 49. Is that not true? So times root 2. The 2 of them are the same, square, bring it together, marry them together, it becomes 49 times 2. See, so 49 times 2 is what? 2 times 9, 18, rather than 8, carry 1. 2 times 4, 8 plus 1, 9, 98. So the square root of 98 to give us this. And the same thing would apply to this. Let me just do it quickly. So, let me do this quickly. Now this is 11 root 2. So what is 11? 11 times this. And then 11 is the same thing, and then you put the opposite, the square root that should bring it down, and the root that should take it up. So what is to bring it down, this to bring it up. It meets at the middle, which is this one. The square root was to bring it down, 11, and the square was to take it up. So just like that, just doing it so you understand. So with this, I want to stop here. Finish it up. It's an assignment. Try to finish it up and let's see what happens. Now let me go back to this. I was supposed to leave this, okay, this was then, okay, this was then 6 times root 2, because I was going to this place, 6 root 2. This was where we started from, 6 root 2. So this came back to this, and this actually could come this way. Now I want you to do this as the assignment, as your homework. And let's see, try your hands on it, and let's see in the next class. It's quite simple, and what is simple to somebody is not simple to the other, but just try your hands on it. Thanks so much. Let's see in the next class.